Hi, Mick McQuaid here to talk to you about building an SQL schema or a SQL schema in SQLite3. So there was a video which I've unpublished from Stan Gunn on doing it in MySQL, and unfortunately that confused some people, so I'm redoing the video using this document, which is what I expected you to use for the assignment, and I think most people did. But this was also here, so I'm replacing it with the video you're watching right now. So building a database schema in SQL, well, first we should define what a schema is. It's a formal description used to build a database. And here is an example of a formal description used to build a database. It has a create table statement, and that create table statement defines the contents of the table. And it may have many create table statements and some auxiliary statements. And I've put the files, I put the schemas for various databases into files in the SQLite examples folder, and we'll look at that in a minute. And I've used the suffix .sql, but that is just a convention. SQLite absolutely doesn't know whether what you're putting in is valid SQL or not. It'll just throw an error message, sometimes a cryptic error message, if what you put in is not valid SQL. And I put in the databases in files with the .db extension, and again, SQLite doesn't know anything about that. In fact, I can demonstrate here. I'm in my SQLite3 folder, and I'm going to create a SQLite database called Drake, and it doesn't care that it didn't have a .db extension. It just created it. And I said tables, and there are no tables in it because I just created it. I didn't put anything in it. And if I exit out of SQLite3 now and say ls -l, -l is for a long listing, Drake, I'm going to get a long listing for Drake, and that's going to include the file size, and the file size for Drake is 0 because there's nothing in it. If I actually put something in it, it would have a minimum of 8,000 bytes, which would be mostly some utility tables that are invisible to the end user. I'm just going to trash this now because I don't need it. The trash command, by the way, I installed using Homebrew on Mac. You can install the trash command with Homebrew, or there are various other utilities for Mac to do that, and then there are some utilities for Windows or Linux to do the same thing. So I also have a Scratchpad file that you can look at, and let's look at that just briefly here. I'm in the same folder in this terminal window. So if I say this, I see that the scratchpad.sql is here. If I say scratchpad, I've done some stuff with the pets database, the cookbook database, is this still the cookbook database? No, that's the Chinook database, I think. This is the Chinook database, according to these comments. By the way, I have syntax turned on. If I turn off syntax, this is the Vim text editor, and it allows me to see the syntax, but the syntax isn't in the file, it's just a feature of Vim. Now, isn't that weird? When I turn syntax on, it actually turns the background black instead of transparent. I like it transparent, so I'm going to just get out of that file for the moment. and go back here and say a little bit about text editors. So Stan Gunn did a video of Sublime. I did a video of Vim, which is hard to learn but powerful and ubiquitous. It's installed by default on pretty much every computer except Windows computers. Microsoft doesn't like it, but it will work on Windows. You just have to install it yourself. And it's useful to use a text editor for your SQL commands. So we're going to talk about some SQL commands here, and I'm going to show them in my text editor. And we may want to take the results of a SQL query and bring it into another document. We may want to copy and paste. And Stan Gunn recommends that you use Courier and Courier New when you're copying and pasting. I don't particularly like those fonts, but they're on everything. So you in Canvas you can get either Courier or Courier New, I'm pretty sure, by saying pre-formatted as your text choice. Okay, and we're going to use SQLite to test our database schemas and run select statements. So we already did this one, I think, as a demonstration at an earlier point of the semester. But here's something a little bit more complicated. Let's do this one. So I could copy and paste this, but I also happen to have it in my SQLite examples folder. See, it's, now I forgot what it is. Oh yes, cookbook.sql. So I'm going to take a look at cookbook.sql. And I've made a correction in this file that was not in the original version on Canvas. That correction is the first line of the file, pragma foreign keys equals on. If I don't have this, these two lines, foreign key and foreign key, lines 22 and 23, are ignored by SQLite. And that's not important for your assignment, but it is important if you start playing around with this database and start doing things that require foreign key constraints. So I put this in, and I put a new copy on Canvas just today that contains this line. Okay, so let's look at what this file has in it. And it's got the schema, and it also populates the database according to the schema. So the schema is just this first part from line 2 to line 24. And when we input this into SQLite, it will record this schema as well as creating it, but it will do it differently from what we might imagine. So let me explain that. So we say create table recipe, and we say recipe ID is an integer and primary key. Well, SQLite sees that, and it's going to auto increment recipe ID automatically. We don't write in auto increment, although we would in most commercial databases. Then it says name is varchar 200. That means that it's varying characters of length maximum 200. SQLite3 converts this to the word text automatically. We don't do that. This would be valid in MySQL, for example, but it's not valid in SQLite3. SQLite3 has a concept called affinities. In fact, let's just take a quick look at the affinities. Here they are. Okay, so this is in the SQLite documentation. The data types in SQLite are just these 5: null, integer, real, text, blob. Okay, and integers are all signed integers. There are no unsigned integers in SQLite3. And we have floating point values in SQLite3, and we have text strings in SQLite3. And by the way, these text strings are encoded on Mac in UTF-8. In Windows, I think they're recorded in UTF-16, but I don't know whether it's Big Endian or Little Endian. You can actually, if you're on Windows, you can actually figure that out by examining the file. Okay, so here are the affinities. Here's a table of the affinities. So we had, for example, varchar 200. Varchar 200 gets converted to text. If we had tiny int, which we don't, it would get converted to integer. We do have tiny text. Where is tiny text? I don't see tiny text here. Anyway, tiny text gets converted to text. And if we had double, double is very common, double precision floating point, that's a 64-bit floating point number, gets converted to real. And all these specialty things get converted to numeric. So Boolean is true and false, but it gets converted to 1 and 0. And date time get converted to numeric fields. And we need special extensions to SQLite3 to correctly handle dates and date times. Okay, so all these things that I told you, tiny text here. Actually, that's the only one I'm seeing. Oh, and another varchar here. So we've created this table, and it's got a name, which is text, a description, which is text, directions, which is text, and an author, which is text. Then we've created an index on name. And by the way, let me suggest that you never use the word name as a name. Name is a bad name. For this table, a better name would be recipe name. I inherited this database, and I didn't want to change it from the way it was because I don't know that I'll necessarily... Well, I probably should change it, but I'm too lazy. That's the real problem. But it should be recipe name. And this name here should be ingredient name. Name is just a bad name in general. Anyway, we've created an index called recipe name on recipe parenthesis name. This is the name of the table, and this is the name of the column in the table. And what this index does is improves performance when we search for name. Now, we're only going to put one recipe in here. Is this? No, that's... Here it is, recipe. So we are only going to put one recipe into recipe. But if we put 1 million recipes in here, if we put enough recipes for a book, for example, for a book full of recipes, searching on the recipe name could be a drag. We want higher performance than we would get. And so in practice in the workplace, you typically create an index on anything that you search on a lot, and we're actually going to search on name here in a minute. We've created an ingredient table with the primary key that again is auto-incrementing and a name, which would be shorter if this were MySQL, but it's not shorter in SQLite. SQLite3 turns this to text and just allocates as much storage as is necessary. And then we've created an index on this name. And these names are, although we might get confused about which is why I said name is a bad name, we don't have to worry about SQLite being confused because SQLite is always going to qualify it with the table name. Okay, and then we have a junction table, which has the primary key for this table, which is auto-incrementing, but then it also has a primary key from recipe and a primary key from ingredient and an amount that we will use. That's really the payload of this. And we have two foreign key constraints. Recipe ID and ingredient ID both reference the recipe ID and ingredient ID from other tables. So as long as we have the pragma foreign keys equals on in place, we won't be able to insert anything in this table that doesn't already exist in the recipe table and the ingredient table. But that still leaves an open question. What happens if we insert something that's valid to insert, but then we later delete the thing that it's based on. There's various possible behavior in this case, and I think I marked a page. Yeah. So here's the page with the foreign key support. And the foreign key support, we can say just foreign key references, and then we get the behavior that we are concerned about for insertion. But then there's also, and these are just examples. Let's see where we can find. Okay, so when there is a foreign key constraint, there's a relationship of a parent table and a child table, and a parent key and a child key. This is not important for you to know about. Oh, wait a minute. There's stuff. No, where is it? Here we go. On delete and on update actions. So if we delete the parent table, we can either take no action, we can restrict, we can set null, we can set default, or we can cascade. So these are relatively complicated actions. We won't go over these in this class, but I just want you to know that you can put in, when you say foreign key, we can say track artist integer references. I guess we don't have to say foreign key if we put this in. I would say foreign key anyway, just for readability. And these are just all examples. Of doing that. But you're going to do one of these 5 things if you are in the workplace. So you should sort of generally know that you're going to either take no action or you're going to take some action. And that action can be to delete the child table or delete all the children of the children or various other actions that I'm not going to get into. So just know that this isn't the whole thing. We could say we could add, before this comma, we could add on update restrict or on update cascade or something like that. Okay, so that wraps it up for the schema. Then we populate the database here, and let's actually do that. Let's actually run these commands. So now I can't remember if I have this. I do have the cookbook database file in there, so I'm going to trash that, and I'm going to say SQLite3 cookbook.db, and then the redirection operator, and then cookbook.sql, cookbook.sql, and this is going to populate. The schema is going to create the database. So when SQLite3 sees a word here, that word is the name of a database, and if it already exists, SQLite3 is going to look for it, and if it already exists, SQLite3 is going to try to open it as a database. And let's say that it's not a database. Let's actually, well, here, let me not get ahead of myself. See, it's a file with 24,000 bytes in it. Why do I always want to type an extra? Okay, let's say that it doesn't exist, and we say SQLite3 cookbook.db without any of that extra stuff. Oops. Now we have an empty database. Okay, and we can actually copy the statements here one by one. I think if I So I have a thing installed here that will copy lines from one pane to another. I want to go to pane number 2, I think. Yeah, so it does that. So see, I can copy the files, the lines individually, but it's rather tedious to do that. I'd rather, let's see how much room that's taken up. It's taken up the default amount of room. So this is the default size of a tiny database or an empty database that has has had at least one create statement. Okay, but I prefer to do it like this. I prefer to do all my editing in the text editor rather than edit within SQLite. It's just more convenient. And then if I say SQLite3 cookbook DB, say tables, I have all 3 tables, and I have stuff in those 3 tables. And I can just hit the tab key after I've said a little bit of the table name, and it will autocomplete. Okay, so now let's do a more elaborate, before I do a more elaborate query, let me just introduce, I think I did this in another video, but let me just introduce it again. If I say mode, so the default mode is this mode here, in which the data is returned with a pipe character between each column. If I change the mode to column and say select star from ingredient, I get a better looking display. But it's not a perfect display, because if I do the same thing but with recipe, I'm just hitting the up arrow to get the other things. If I say select star from recipe, there's word wrap going on, so it looks ridiculous. So this screen, I actually measured this display earlier, and it's 46 characters wide, and this line is more than 46 characters, so it wraps around here, and then this, in the middle of the word salt, it's wrapped around. So instead, I can say mode column wrap, let's see, dash dash wrap. I can say 46 or any number smaller than 46. And I get a better looking output, more readable output. I can even refine it a little bit further by saying word wrap. You'll notice, so SQLite, I'm going to say word wrap on, and notice here that pan has a comma after it, and the comma went to the next line. In SQLite3's mind, pan comma is one word. Any sequence of characters other than a space is a word. So taste dot is a word. Fluffy dot is a word. Pan comma is a word. But if I turn word wrap on, and then I do the same query again, pan comma gets wrapped to the next line. So this looks better still. I'm not restricted to all these. Let me say help mode. And I can output an ASCII art table. I can output tab separated values. I can output a markdown table. I can output a JSON array, an HTML table, a CSV table, whatever I want. And those are often very useful, because if I say mode.csv and then I say import a CSV file, I can actually avoid writing all these, if I have an Excel file or something that I can convert to comma separated values, I can avoid writing all these insert statements. I can just import that data in. And if I need the insert statements, I can then dump that data out using the, using what? I can't find it now. If I just say dump the table, let's see if dump is a command here. Yeah, if I dump the table, it will dump it in this format of insert statements. Okay, so I think that's all. Let me look back here at our that's not where we were. Here's where we were. Okay, a couple more things to say about this file. There's a more complex query that we're going to do here. I think that's also in my Scratchpad file. So am I in the right? Yeah, okay. I'm in the right place now. So here is a way, if I want to, let me just select star from recipe ingredient to illustrate this point. So if I look at the recipe ingredient file, it's not really obvious to me what's going on. Number 1 refers to recipe number 1, the scrambled eggs recipe. That's number 1 for the ingredient ID. So there are 3 different ingredients. Actually, there are 4 ingredients, but only 3 are used here: butter, salt, and milk. That can't be right. Oh, I already inserted eggs in there. This is number 1 in the ingredient table. Eggs. Number 2 is butter, and number 3 is salt. So milk and black pepper are the ones that I haven't bothered to use here. So I have eggs, butter, salt. And then the amounts are 4 eggs, 1 tablespoon of butter, and 1 pinch of salt. But I only find that out in the amount is only in the recipe ingredient table. Okay, and then I haven't used the directions. I've basically just said in my query, I've said that I want the amounts from recipe ingredient, the name from ingredient, where the recipe name is scrambled eggs, and I also want the recipe ID to equal the recipe ID in the junction table, and the recipe ingredient ID to be equal to the recipe ingredient ID in the junction table. Okay, so this is hard to look at. This is easier to look at. This tells me a little bit more clearly what it is that I'm looking for when I'm looking for scrambled eggs, for the ingredients for scrambled eggs. That's the point of that. And then I think I already told you the data types: null, integer, real, text, and blob. This is significant. Let me do this, so I can say select distinct. See, now you know why my screen is translucent, so I can copy from things that I don't remember off the top of my head. So I said varchar 200 for the name and recipe. But if I query the type of using the type of function, I get text. This is the only way to know what the real type is the type of function. And if I say .schema, I just get what I put in. It doesn't do the translation automatically. This is just all the stuff that I typed in. Okay, so that's significant to know about, and I think that pretty much does it for this. So thank you for your attention, and I'll see you next time.